And everyone, I am from Indian Space Team and member of Indian Space Team PR department. Today's we talk about how old our Earth really is. As it turns out, the answer lies in the vast expanse of our cosmos, in the oldest material found in our solar system. This cosmic relic traces its origins back to approximately 4.5682 billion years ago. Quite a mind-boggling figure, isn't it? To understand the birth of our planet, we must first delve into the formation of the solar system. Picture this. A solar nebula, a cloud of gas and dust in space, begins to collapse under the weight of its own gravity. As it collapses, it starts to spin and flatten into a circumstellar disk. This is the birthplace of planets, a cosmic nursery, if you will, with the sun at its heart. Within this nebula, tiny particles of gas, ice grains, and dust, including primordial nuclides, start to come together, drawn by their mutual gravitational pull. They begin to form larger and larger clumps, a process known as accretion. These clumps, or planetesimals, are the building blocks of planets. It's within this cosmic whirl of creation that the primordial Earth begins to take shape. From the first speck of dust to a fully formed planet, it's estimated that the Earth took anywhere from 70 to 100 million years to form. Quite a lengthy gestation period even by cosmic standards. And there you have it. The birth of our planet, a process that took billions of years, beginning from a cloud of cosmic dust and gas in the vastness of space, to the formation of a planetesimal, and finally to the Earth we know today. That's quite a time, isn't it? But the Earth's story is just beginning. So let's keep journeying back through time to understand how our planet, our home, has evolved into the world we know and love today. The story of Earth is a fascinating tale of cosmic forces, astronomical events, and the unstoppable march of time. Ever gazed at the moon and thought about its origin? That bright, beautiful orb in the night sky has a history as fascinating as it is complex. Theories about the moon's formation range widely, with some suggesting it's as old as 4.5 billion years, while others propose it might be significantly younger. One particularly compelling hypothesis involves a celestial body named Theia. Picture this. Billions of years ago, a Mars-sized object, Theia, hurtling through space, collided with the still-forming Earth. It wasn't a direct hit, but rather a glancing blow, with a chunk of Theia's mass merging with Earth. The impact was so immense that it loosened material from Earth, which later accreted to form our beloved moon. This theory, known as the giant impact hypothesis or Theia impact, is currently one of the most widely accepted explanations for the moon's formation. It accounts for many of the moon's unique properties, such as its size relative to Earth, its orbital characteristics, and the similarities and differences in the composition of the moon and Earth's crust. Moving forward in time, between approximately 4.1 and 3.8 billion years ago, our moon underwent significant changes. This period, known as the Late Heavy Bombardment, was characterized by numerous asteroid impacts, which scarred the moon's surface and created many of the craters we see today. The Earth wasn't spared either. The bombardment likely caused drastic changes to our planet's surface environment, although Earth's active geology over time has erased most of the direct evidence of this ancient asteroid shower. Through all these dramatic events, the moon has silently borne witness to Earth's own evolution, its pockmarked surface a testament to the volatile history of our solar system. So the next time you look up at the moon, remember its journey. It's not just a pretty sight in the night sky, it's a celestial body with a history as rich and as complex as the Earth's. So, the moon we admire so much today has quite a dramatic origin story. Ever wondered how our oceans and atmosphere came to be? It's quite an intriguing story, let me tell you. Our planet's atmosphere and oceans didn't just appear out of nowhere. They were the product of intense volcanic activity and outgassing. Picture this. Countless volcanoes erupting, spewing gas and ash into the young atmosphere. The expelled gases, mainly water vapor, carbon dioxide, and nitrogen, were trapped in the Earth's gravitational field, gradually forming an envelope around our planet. But where did all the water come from? The answer lies in the heavens. The water vapor expelled by volcanoes was supplemented by water and ice delivered by asteroids, protoplanets, and comets. These cosmic water carriers bombarded the Earth, releasing their precious cargo upon impact. Over time, the water vapor in the atmosphere began to cool and condense, forming droplets that coalesced into clouds. Eventually, these clouds became so heavy that they couldn't hold their moisture, and it fell as rain. This process continued for millions of years, with the rainwater pooling in the planet's low areas, gradually forming our oceans. But there's more to this story. The early Earth was continuously bombarded by solar wind, a stream of charged particles emanating from the sun. This could have stripped away our fledgling atmosphere, if not for the formation of Earth's magnetic field. Around 3.5 billion years ago, the churning of molten iron within Earth's outer core generated a magnetic field. This invisible shield deflected most of the solar wind, preserving our atmosphere and allowing it to evolve into the life-supporting blanket of gases we enjoy today. So next time you take a breath of fresh air or sip a glass of water, remember the incredible cosmic journey these elements have been through. The air we breathe and the water we drink all are the results of these natural processes. When did life first appear on Earth? This question has intrigued scientists for centuries. The answer lies in the complex process of our planet's evolution and the formation of a protective ozone layer. Let's take a step back. Our early atmosphere, rich in gases like methane and ammonia, started to change due to the activity of the first organisms, which were simple microscopic cells. As these tiny pioneers thrived, they began to produce oxygen through photosynthesis. Gradually, the levels of oxygen in the atmosphere increased, and over time, this oxygen, interacting with ultraviolet solar radiation, formed a protective ozone layer in the upper atmosphere. This ozone layer was a game changer. It absorbed the sun's harmful ultraviolet radiation, making conditions on Earth's surface much more hospitable for life. As the environment became more suitable, life started to get a little more complex. The next big leap in evolution was the development of eukaryotes. These are complex cells that have a nucleus and other specialized structures. This significant step happened when smaller cells started to live inside larger ones, providing benefits to each other in a beautiful example of symbiosis. With the advent of these complex cells, life on Earth began to diversify and flourish. The ozone layer's protective shield meant that life could now colonize the surface of Earth. Organisms started to grow, multiply, and evolve into an array of forms, from the tiniest microbes to the largest dinosaurs. Our understanding of when life first appeared on Earth comes from the fossil record. Among the earliest fossil evidence for life is microbial mat fossils found in 3.48 billion-year-old sandstone in Western Australia. These ancient fossils offer a glimpse into our planet's ancient past, a time when life was just beginning to take hold. So when did life first appear on Earth? The answer is billions of years ago. From simple microscopic cells to the vast biodiversity we see today, life has been persistently and resiliently making Earth its home. Our planet has been teeming with life for billions of years. Did you know Earth has experienced major changes and extinctions? Let's delve into this fascinating chapter of our planet's history. Imagine, if you can, a time around 1,000 to 539 million years ago in the Neoproterozoic era. Picture a world almost entirely covered in ice, a chilling vision that scientists refer to as Snowball Earth. This icy period is not just notable for its extreme climate, but also because it set the stage for a significant event in the history of life on Earth, the Cambrian explosion. The Cambrian explosion, occurring around 535 million years ago, marked a period when multicellular life forms began to significantly increase in complexity. It was during this time that the diversity of life on Earth took a dramatic leap forward, introducing a plethora of new species and laying the foundation for the complex ecosystems we see today. However, life on Earth hasn't always been a tale of progressive evolution. Our planet has borne witness to at least 5 major mass extinctions and numerous minor ones. Each of these events has punctuated the steady march of evolution, causing widespread species loss and dramatically reshaping the course of life on Earth. The most recent of these mass extinctions occurred around 66 million years ago, marking the end of the age of the dinosaurs. This extinction event, triggered by an asteroid impact, wiped out the non-avian dinosaurs and other large reptiles. Interestingly, it largely spared smaller animals such as insects, mammals, lizards, and birds. It was this event that paved the way for mammals, including our own species, to rise to dominance in the post-dinosaur world. Earth's natural history is a tale of creation, adaptation, and survival. It's a story that continues to unfold even today. Please share this video for improve your friends' knowledge.